Let me tell you a little bit about myself to give a little bit more background as to how I got here. So, I'm a user experience designer, and I have the basically I've been designing for the web. This will mark 20 years of designing for the web and being a user experience designer. It's strange to have been a web designer 20 years ago, but this is some stuff. This is a navigation bar that I did in 1994, and the reason that I showed is I'm actually really proud of it. I think it actually looks still pretty good, and and they were still using the same identity in 2010. So I had the privilege of designing the oldest pixels on the internet at that point. So, and this means that I've seen two .com busts. I've watched a lot of my clients fail. I worked for Pets.com, and I watched a lot of stuff disappear overnight. A lot of really good thinking and hard work. And so this gives me some distance from it. I've done a lot of user experience design, so this is actually kind of one of my last web-only clients, which was a couple of years ago for credit.com. So I kind of art directed that and designed the UX that. I've actually spent most of the last 6 years working on the user experience design of consumer electronics products from a lot of companies you've heard of. And I wrote a couple books based on my experience as a designer. I wrote Observing the User Experience, which is now in its 2nd edition as of a couple months ago. And it's a cookbook of user research methods. And I wrote Smart Things, which was essentially based on my experience doing the kind of device design that I showed you, essentially designing for those kinds of devices. And a lot of that ranged from everything from kitchen appliances to embedded hardware to, you probably saw there was a piano in there. And during this period, during this whole time, I started 2 companies. One is Adaptive Path, one is Thingam. The thing about Thingam Thingam was my attempt. We started 6 years ago, 7 years ago, and I was really done with the web at that point. I've been on the web for a very long time, and I was really, really tired of the web. And so I was like, what does user experience design look like when you go away from screens? When you go away from essentially real estate management on a pixel background? And so that actually led me to this very strange place where we essentially ended up designing and selling and manufacturing hardware. And essentially doing everything from the firmware to the board design to the user experience design of the tools to work with this. And that was a fantastic experience. Also really taught me how hard hardware is. But Thingam still around, still does that. It's used for a lot of architectural stuff, a lot of prototyping stuff. It's Lady Gaga's costumes and stage show use our stuff. Although you're not allowed to know that, I think I'm not allowed to know that. So, but a couple of things that we did was that we actually spent a lot of time exploring. Oh, by the way, this is pretty low. Am I blocking it for a giant chunk of the audience? I can just sit down. And, okay, why don't I just sit here? I saw somebody craning that head, and I was like, oh, that's gonna be hard. One of the things that we did is we actually spent a lot of time exploring digital technology, digital hardware technology as a medium, and that actually put us, essentially as an expressive medium, as a design medium, and that put us squarely in the place of the Internet of Things. And so, the thing on the left there is a wine rack that we did for a Wired magazine event 6 years ago. That is a RFID wine rack that talks up to a cloud-based service and displays metadata about wine on the wine itself using, for those of you who are information architects, a faceted classification system so that you can slice and dice through the wine space and presented directly on the objects themselves. The idea was to essentially take a physical experience and enhance it in a digital way without without making people look at a screen, essentially, without essentially mediating that experience. That's one of the differentiators for me between the Internet of Things and essentially augmented reality. Augmented reality is clearly a mediated experience of the world, whereas the Internet of Things is very much a literal experience of the world. And we've been really trying to explore that. The thing on the right is a capacitive sensing kitchen cabinet knob, and what that glows when you approach it and touch it, and then kind of glows randomly, so it kind of flickers at random times. And the idea was, there were kind of two perspectives on that. One of them was to think about kind of jewelry for the home. You know, what is digital technology that is purely decorative, completely non-functional, that is purely uses digital technology to decorate the world. And the second thing was, how can we make a digital object that is still useful and interesting for 20 years? And so how do you make things that are inherently digital but are inherently still valuable? And this is again, thinking about digital technology as a medium. And so, so those are a couple experiments that we made. That led into a whole bunch of work that I can't talk about, and one thing that I can. So last year I worked with SFIO, and I redesigned the non-game user experience of SFIO's cubes for their second edition, which came out for last Christmas. So they were a fantastic client. And I was very happy to work on that. If you haven't actually seen, this is one of the best Internet of Things products that's out there. It's also a great game. They just released three new games this week. I'm totally going to plug them because they're great. So about a couple of months ago, I joined PARC, the famous research lab that invented everything in the 70s. And I joined full-time as a principal in a relatively new group called Innovation Services, which is as kind of clearly defined as the name implies. So a lot of my work with that and also around it is pretty much Internet of Things work. But before I delve more into the Internet of Things, I wanted to talk about the name. So talking about the Internet of Things is really hard because there's so many different definitions. So this is Time Magazine's illustration of the Internet of Things for their Best Inventions of 2008 edition. So for those of you who think the Internet of Things is new, Time thought it was awesome in 2008, which means that it was probably already over the hill at that point. So, basically it's like, as my wife said, you know, when the New York Times writes about a fashion trend, that means it's already passed. So the reason that I put up here is that I actually love this illustration because it makes no sense, no matter how you look at it. No matter what you do, it makes no sense. And I think that that's actually because all the definitions of the Internet of Things are really internally confusing. So what I want to do now is, before we move forward on this, let me give you my definition. And my definition is probably equally as confusing and broad, but let me tell you kind of what my definition of the Internet of Things is. For me, the Internet of Things is distributed computing plus pervasive networking, usually wireless, but not necessarily. Automatic identification, so you can uniquely identify things. And this is, of course, where the name starts, right? It starts with Kevin Ashton talking about RFIDs, but really, for me, it's uniquely identifying things and being able to talk to them in a networked way. Plus, it's got to be cheap, because it's not, the internet, if it's not cheap, if it's not widely, easily distributed. So those, this combination of things, for me, is what creates the power of, it essentially aggregates the power of a lot of things. Because for me, what it does is that essentially, when these elements combine, what they do is they allow physical actions in the world to become knowledge up in the cloud, and they allow knowledge up in the cloud to be projected in a physical way in the world, in a way that's never been possible before. And that, to me, is the real power of the Internet of Things, is this two-way communication between network cloud-based services and the physical world. Not the world of pixels, but the actual physical world. So what that means is that if you look at SenseAware, and how many of you are familiar with this product, the FedEx SenseAware product? Awesome. All right. And Yadamark, how many of you are probably a few people familiar with Yadamark? Okay, same person, awesome. So SenseAware tag is actually a FedEx product. So it's made by Federal Express. So the SenseAware tag is a little. It's a little instrument cluster that has a bunch of sensors, a GPS, and I think basically the equivalent of a phone in it. And what it's used for is it's used to track high-value items, such as human organs, that really need to be shipped under really precise conditions. You need to know where that thing is, and that it's always being kept in the same conditions. So it's worth it to have this device, which probably cost FedEx $50 to make, and they probably charge you like $1,000 to use. Or I don't know any of this, so I'm just guessing. But the point is that it's worth the money when you have something that's that valuable. Yadamark is essentially the opposite of the scale. Yadamark is essentially about stickers. So they use stickers, readers, and essentially a wireless network to track things such as produce, in this case cantaloupes, right, and car parts. And if you think about these two systems, there's almost no technological overlap. One is sensor package, really super sophisticated sensor package. One is stickers. But to me, I think they're actually both the same. They're both part of the Internet of Things, because what they're both doing is they're treating physical things like data packets. They're treating physical things out in the world like data packets out on the Internet. And that makes them both equal members of the Internet of Things. So, the short version is that, here's the Internet of Things. So this is the 2012, this is July 2012 Gartner Hype Cycle. How many of you know about the Gartner Hype Cycle? Oh, the rest of you gotta Google Gartner Hype Cycle. This thing's awesome. So basically what it does, it takes all the technologies that everyone talks about and says, and talks about how and when they're gonna fail. It's great. So the reason that, so right here you can see it's the trough of disillusionment. What's in the trough of disillusionment? Virtual worlds. Virtual worlds are the trough, is at the bottom of the trough of disillusionment. Where they belong. Because eventually, maybe they'll climb up and they'll enter the slope of enlightenment. See, this is why I love the Gartner Hype Cycle. So for me, the reason the Internet of Things is climbing the Gartner Hype Cycle, while at the same time, if you notice, it's got a little yellow triangle, it says that it's not going to actually mature for 10 years, or for more than 10 years. I mean, the reason that it's climbing this at all now, even though of course Time was talking about it 6 years ago, is the rise of smartphones. And it's the rise of smartphones that have pushed the price of components down and have made people a lot more aware of what happens when you take a small bit of digital functionality, and essentially what an app is, right? That's a small little bit of digital functionality, and then you distribute it throughout the world. And so what's happening is that people are looking at apps, I mean, from my perspective, and they're thinking to themselves, why do I need this small bit of functionality inside this really expensive phone? I don't actually need all those capabilities. Why don't I yank it out of there and make it its own device? Why don't I take that app and turn it into a dedicated piece of hardware that only does that one thing that I want it to do? So that, I think, is why it's climbing. We'll see, again, the point of the Gartner Hype Cycle is that at some point there's going to be some disillusionment, and you got to kind of power your way through that. unless you're virtual worlds, in which case you might just be stuck. Sorry, it's not that I hate virtual worlds. It's easy to pick on Second Life. So one of the things, like while I'm talking about the definition of the Internet of Things, one of the things that when you look at a lot of the ways that people have been talking about Internet of Things, like if you look at, like Europe's been really excited about the Internet of Things for about 10 years, 8 years, something like that. And they've got all these reports, and China's really excited about it. They have all these reports, and they've essentially started Internet of Things cities and things like that. And if you look at all of that, almost all of that is really top-down. So it's really about large-scale infrastructures. Smart grids, building control systems, sensor networks. Here's, San Francisco has one of these, right? If any of you use the streetline stuff that SF Park put out, that's in North Beach, that's totally Internet of Things. There's a wireless sensor that's stuck into one of those little road bumps in the roadbed, and it senses your car, and it sends that data up to the street light, and then that sends it up to the internet into a cloud service where you can figure out where there are parking spots on your phone when it works. Although it really generally does work. But the thing is, for me, is that this is a quintessential kind of traditional top-down Internet of Things project. I just don't think that these projects are actually the ones that are going to have the largest impact on the world. I think they're interesting, but I don't think that this is where kind of the meat is going to be. And I think the greatest impact, the greatest innovation, will actually come from much smaller, much riskier projects undertaken by entrepreneurs such as you, using existing infrastructures. Not building new infrastructures, but using existing infrastructures. So, next, kind of continuing on this. So, how I believe this will happen is that people will now start taking online services into the physical world, as I explained, with specialized devices. And let me kind of show you why that is. I kind of alluded to it. So, there's a couple of shifts that I like to talk about. One is the shift from generic devices, which is the thing you see on your left there, right? Laptops, office suites, browsers are incredibly generic. They're designed to be used under any circumstances with any kind of content, with anything. So what we're seeing a fragmentation of the world from generic things, generic devices and software, to highly specialized devices and software. So, when computing was really expensive, when you really had to pay for every cycle, you had general purpose devices because you could only have like one, maybe two of them. And general purpose software that had to deal with nearly every situation. What this did is this necessitated design compromises in both, so that it could both do almost everything but did none of it very well. Now that processing is really, really cheap, you can have a combination of devices and software. Instead of 2 things or 3 things, you can have 10 things or 20 things. And those things can be partly physical, partly virtual, partly running locally, partly running remotely. And you can do all that for the price of 1 device and 1 piece of software in the old days, i.e. 5 years ago. And when you need to acquire new functionality, this means that you don't have to acquire an entire new general purpose device or an entire new general purpose package. You acquire 1 thing, 1 tiny thing that only does 1 thing. A friend of mine who's been doing mobile design for 15 years. It's kind of the Nokia, system, whatever days. He complains. He's like, nowadays an app is something that we would have called a minor feature. Someone launches an app, and we would have been like, yeah, that's kind of a thing that's like 2 levels down in the tree. I'm like, of course, because nobody found those things back then, and it's not the point. Right? The point is that the 3 people that needed that can now just get that part of it. They don't have to, get your entire phone platform to do it. So the second trend that I want to talk about, which I mentioned before, is that now much of everything is now remote. There's no longer, like back in the old days, you'd have everything, as I said, just packed into a single piece of software and it was running locally. And you'd expect that somewhere in some menu item and some special thing is the thing that I want to do. Excel is the classic example of this, right? It does everything. It actually, whatever you release, it has to do some more. Now you get things like Mint, right? Mint only does the one thing. It's very similar to Excel in many ways, but it only does the one part of it that you want, and it does most of it remotely. And so your expectations for the piece of the thing that you're working with have really shifted to the fact that the value is actually not local, it's remote, and the value is not general, it's specific. It's a really deep change in people's expectations for the experiences, the digital experiences they have. So if we chart these two trends, we get two classes of digital products. So if we follow the local to remote trend, you get this class of products that I call terminals. They're essentially, they essentially do the same thing, and the way they differ is they differ in size. So nowadays, you have a terminal of virtually every size, from a 2-inch diagonal up to a 100-inch diagonal device, so like literally in 2-inch increments. You can get the, from soon-to-be watches to phones to phablets to tablets to big tablets to little laptops to big laptops to little TVs to big TVs, and literally the whole gamut has been filled. The whole ecosystem has been filled in 2-inch increments. So if you follow the other axis, the general to specific axis, you see a focus in a really narrow functionality. Essentially devices that could be general. Like I don't know if any of you remember, like there was this period 12 years ago when every new device that ran that could potentially run Linux that came out, somebody ported Linux to it and was really excited that you could play Doom on it, right? and it's like, yes, you can play Doom on that camera. Who cares? Now it's completely accepted. Because, but the point is that you're getting these devices that essentially the way they differ is they differ in terms of the really narrow specific functions that they do. And I call these devices appliances. And so, okay, I think you guys get the distinction. I also have a third category, which to me is, and obviously there's a square that's missing here, right? To me, the square that's missing is of devices that are simultaneously specific and deeply tied, and remote essentially, deeply tied to online services. Where the service provides the majority of the value, and it can be represented as either a dedicated appliance or an app running on a terminal, or anything in between. I call these devices avatars. Taking the name back from virtual worlds. And returning it back to its original, closer to its original meaning, Hinduism. Anyway, I digress. So let me talk about, and these are avatars of services, specifically of online services. And this, for me, is where the Internet of Things lies. So what you see is you start to see is that the value kind of shifts from devices to services. Software applications and essentially the value of each avatar actually becomes secondary. And what's important is the service that avatar connects to. Essentially a camera becomes a really good appliance for taking Flickr photos, while a TV becomes a really nice Flickr display that you don't have to log into every time. And a phone becomes a really convenient way to take your Flickr pictures on the road. That's how you're looking at these devices. You're looking at them in terms of what services they give you access to. The things that are giving you that access, they're actually not as important. A really good example of this, my favorite example of this, is Netflix. So you can get Netflix on virtually any terminal that has a screen and a network connection. You can pause a Netflix movie on one terminal and you can unpause it on another one. To the Netflix customer, any device that you use to watch a movie on Netflix is literally a hole in space to Netflix. Essentially, the device holds a short-term manifestation of that service. The value is not in the device. It is not in the black frame around Netflix. It is in the service that the frame provides you access to. The technology exists to enable the service, not as an end to itself. So for example, Roku exists essentially to give you access to Netflix and Hulu on terminals that don't already have it. When all terminals have Netflix and Hulu, you won't need one of these. So this to me is why the Internet of Things, from my perspective, is really based around services in the cloud that talk to specific hardware devices as avatars. The hardware becomes the competitive advantage in terms of how the service is presented. So let me use WeThings as an example. So for those of you who don't know, what WeThings is, Google it on your terminal. So WeThings is a scale, right? So originally, it was marketed as kind of a gimmick. Ooh, you can tweet your weights to your friends. That sounds like a terrible but of course that wasn't the purpose of the device, because the purpose of the device is that the scale is an avatar to a health service. It's the way that you get that data into the, like, you could have put that same data, you could have had a health service and put that same data into an app on your phone, but you're not going to do that because it's one extra step. The scale short circuits that and gives you access to the service. It gives you the value of the service using this specialized device. The device is the competitive advantage. The value is not actually in the scale. The scale is not the valuable part. The service is the valuable part. And the service, as you can see from this ad, is actually experienced through other avatars. The scale only gives you a very small amount of information. The real value is all right here. Moreover, WeThings, once they have, of course, established the service, can now expand the service to other avatars. When WeThings added the blood pressure cuff, they didn't add it as a separate service, they added it as an add-on, I believe, to their existing health service. Now again, the value is not in the device. The value is in the knowledge that's created by the device, that collects that single piece of information and provides people then with the full value of the cloud service behind it. So WeThings can actually keep adding avatars. It can keep adding avatars and sensors and new ways to collect information and depict information without fundamentally changing the promise of the service. And in fact, they're about to add another one. They're about to add a Fitbit competitor. You know, they're about to add an activity tracker. So this thing's, you know, it's the same size as a Fitbit. It's this big. So it's of course a logical extension of the service, but it's a completely different hardware platform. It has nothing to do with either the scale or the cuff, and yet it's part of the same thing. It's an avatar of that service. So meanwhile, Fitbit is going the other way. Fitbit has added a scale. So Fitbit sees that the value again is in the service, and they're actually, even though WeThings made scales and Fitbit made pedometers, they were actually in the same business. Anyone from Fitbit here? Oh, am I right? Mm-hmm. Thank you. All right. So there's essentially this entire class of devices that are essentially projections of services through limited hardware products. You know, it's the quantified self crowd loves this stuff. There are, you know, but the thing is that no matter what the sensor is, no matter what the sensor-based device is, the value is in the service. It's not in the device. So my favorite of these, and I've been talking about this for like 5 years. This is one of the most mature of these services. And I'll keep talking about this because it's genius and I love it, is the Vitality Glow Cap. So the Vitality Glow Cap is a wirelessly connected pill bottle cap for increasing compliance to drug prescriptions. So there's the pill bottle cap. When you, it's got a little light on top, but I actually have one. I should bring it in for some of this next time I do this. So you open this thing up, you close it again, it sends a packet of data through this back thing, which they call a nightlight, but it's actually a phone. And it's plugged into the wall. And what it does then is it then resets the timer on this, and it sends a little packet that says you took your medicine. So the timer is really useful because you know, 8 hours later, whatever your prescription is, it'll glow red again. And you know, if you don't take it, it'll blink. And then if you still don't take it after a while, it'll start making noises. You know, that's great. But the real value is in the packet of data that it sends up to the cloud, where that data is aggregated, and that data can be manipulated and projected back to other avatars. So you get a progress report, or your loved ones get a progress report about how you're doing in terms of your drug compliance, in terms of your medicine compliance. Moreover, your doctor gets a different one. Your doctor gets one that's a longitudinal one across time. So that if you come in and you're complaining of certain problems, they can look at this and they go, oh, you didn't take that thing for 2 weeks. You know, you forgot it for 2 weeks. I'm not surprised why you have a headache. You know, or whatever, you know. This system, which is now, again, I'm going to plug them because it was started partially by friends of mine. Compliance, when they tested compliance to prescription regimens, goes up from like the 60%, like somewhere around 65, 68%, into the 90s. It's fantastically effective. It's fantastically effective because it is a small bit of data that enables a cloud-based service that then feeds back into people's relationships to increase compliance. It's a great use of technology. So, you know, obviously this kind of stuff isn't just in health technologies. You know, it's maybe, it's moving into home technologies. So, kind of life and work environments. So on the left is Lockatron, this is kind of their first generation product. It's essentially an internet-connected lock, so you can make your Airbnb guest apartment available to somebody for just the weekend. So they open it with their phone, and their code only works for 3 days, the 3 days they paid for it, and then somebody else gets a different code. Or, you know when your lock has been opened or closed. Super, super simple. They essentially built a little board on top of an existing electric lock platform and connected that to the internet. The second version of this is even smarter. I'll show you that in a minute. But basically, it's just literally this super simple cloud-based service that enables this incredibly important human activity. This right here is Cube Sensor. It's still being kickstarted. They're, I think, about a week away, but they, I think, got a whole bunch of money. So what they're doing is they're essentially packaging a whole bunch of sensors into a little cube you sit on your desk, a little cube that you sit on, that sits on your desk, and then there's a cloud-based service that makes sense of all of those sensitive data, of all of the, I don't remember exactly what they're collecting. But they're collecting a bunch of data, and that allows them to give you this really valuable information about your immediate living environment. Or they sell them packs of 2, so you can have one for home and one for work. So you can really tell what your environment is like. So that's great. But what's really important to me is actually how are we going to get to making more things like this? And let me take a step back. Let me take a step back to my web days. So. If we step back and kind of examine kind of the previous sea change, from my perspective, in terms of the way the technology is developed, essentially the Web 2.0 movement that led into lean startups, we see essentially a bunch of tools that enable people to rapidly build and iterate on ideas. So there are a bunch of tools. So Web 2.0, when it came out, people were like, oh, all these technologies, they've existed for 4 or 5 years. What's new about this? What's new is the combination of things. The combination of things and the maturity of the environment in order to be able to absorb it. And so what happened is that you got a bunch of tools like Ruby on Rails, like virtualization, like jQuery, like GitHub for collaborating. All this stuff. What it allowed people to do is that each one of these removed a layer of complexity from that stood between you and your instantiating your idea in a piece of technology. Each one of these essentially lopped off a big piece of that, so that you no longer had to worry about that, and you could really focus on the idea itself. I don't know if any of you remember before, virtualized servers, server provisioning, you had to pay a sysadmin to run your own Unix server, and a database person to run a database. That seems like absurd today. Like, why? Like, you just pay some service $30 a month and they just do it. It didn't exist until 10 years ago. It just didn't exist. And when those things appeared, and when this entire cluster of stuff appeared, that's when you could start really focusing and iterating and digging deep. We're starting to see that happen in hardware now. We're starting to see that happen in the physical world. So every couple of months, a new technology comes along that makes it easy to add specialized hardware to cloud-based services. So the top image is from Ramp, which is a company that essentially they make a little hardware blob that essentially connects virtually anything. In this case, their example, the smoke detector, to their cloud service. And the bottom one is, of course, Electric. Anyone here from Electric? No? These guys are great. It's a great product. So essentially, it does the same thing. What it does is it's very much like the tools that I was talking about, in that it drops the barrier to entry to connecting a hardware thing, up to a cloud service significantly. Not all the way to zero, but significantly. It's what Twine does, it's what NinjaBlocks does. There's a whole class of these, essentially what the large world would call middleware devices that make it easy to connect stuff up to the cloud. Moreover, and so you can see that actually Logitron, the first time they developed their own board. They had, well, the second time they also kind of developed their own board, but the first time they had to develop all this like network infrastructure. The second time they just, this is literally announced a couple days ago, right? Like less than a week ago. They're like, why don't we just work with Electric Hammer? They've actually solved all these problems. Well, we'll just include their tiny little board in our thing, and we'll be done with it. So, this is essentially exactly that process that I described happening in the physical world. And moreover, there are a lot of services up in the cloud that are kind of coming out. There's Cosm, also known as Patch Bay, ThingSpeak, Everything down here. We're great guys. Exida, they're essentially serving as data brokerages. What they do is they allow arbitrary different devices to act essentially consistently. So what they do is they take an arbitrary data stream from one device, or let's just say Patch Bay takes an arbitrary stream from one device and allows it to share that data stream with another device. And what it does in the middle is it does the buffering, it does the protocol translation, it does the analytics, it does all the stuff that you want to know about how those two devices are communicating without you having to build any of them. You just talk to it in a fairly standard way. It's all completely open, and these days it's all completely free because they're really interested in the data much more than they're interested in kind of getting money to buffer stuff. And they make it really easy for you to bring these things online. So connecting data devices to the cloud is allowing people to do more rapid iteration. We still don't have the rapid iteration of kind of lean startup style cycles, but we're getting there, right? The train is starting to go chugga chugga, right? Not very technical sense. So Park's contribution to this is actually a set of technologies. I'm gonna, because I think Park is doing great stuff. I don't want to belabor it, but I want to give you a little plug for what, especially if you're working on technologies, what Park is doing. So Park is doing a set of, I think, really interesting things. We are developing a set of electronics for set of technologies for printing electronics in a wide variety of description of printing. But really imagine inkjet printing on a flexible substrate, and you want a new circuit board, you want it for a wearable, you literally stick a sheet of material into a thing that's like an inkjet printer, and it prints a circuit board for you. You take it out, you cut it out, you put components on it, and it works. So we're building that. We have partners that are actually productizing it. We have a project for content-centric networking, which essentially inverts, essentially think of it as like BitTorrent for everything. Like they wouldn't want me to say it, but like call it that. But basically, you want to use your device needs some kind of service. Like, you know, I really need a temperature sensor. Where can I get a temperature sensor? Right now, you have to have an intermediate broker like Patchbay that essentially says, there's a temperature sensor. In this room right now, there's probably a dozen temperature sensors of some sort. And yet none of our devices can find them. What content-centric networking does is it says every device that's connected to the net locally, essentially, you know, which of you have a publicly available temperature sensor? Oh, it's you over there. I'm just going to use your sensor right now. So what it does is it allows you to essentially do service discovery across a wide variety of devices. We're also doing digital manufacturing. So essentially, we're applying machine intelligence to the process of manufacturing a thing, so that it really lowers the bar to actually making the physical part of it. Like often the hardest part of making a device is actually the injection molding, or you know routing the CNC mill so that the aluminum case does the right thing and fits your part. We're making a set of technologies that make it much easier for you to do that. You know, that'll essentially do some of the stuff where you'll say, I've got this set of devices, can I make this? And I'll say, no. Try again. And I'll go, oh, how about this? Oh yeah, that can make. So, and then we're also doing a lot of ultra fast classification of enormous data sets. This is a project I can actually talk about. I worked on a project where we were essentially looking at the entire Twitter fire hose and classifying it in near real time. So we have some very interesting machine classification technologies. So that's kind of the main outline from my perspective of, here, let me start this thing. Will it work under this? Okay, so this is actually a film by Timo Arnal. This is called Wireless in the World, and I love this film. I'm just going to talk over it. So, for me, this all this stuff still leaves us with a problem. You know, how do you design experiences that involve dozens or hundreds of devices? You know, the key for me to the Internet of Things will not just be because of how cheap the hardware is. You know, that's a necessary but not a sufficient condition. Right? We need ways to think about how to create value from sets of these systems, from lots of these systems simultaneously, and to create multi-device user experiences. And for that, we need a new set of tools and a new set of metaphors for understanding the behavior of many devices simultaneously. That's obviously why I started showing this film. Unfortunately, right now, and I recommend you see the rest of it, but not really. Unfortunately, our current Internet of Things tools are from the pre-Internet of Things era. They're all from the computing is expensive and deterministic era. They're designed for creating things that work on one device. And this very rigid kind of command and control approach fails for when you move up to many devices. You know, really, in many ways, we still haven't actually come up with a better way of thinking about how to design multi-device user experiences then you can see in this picture from 1984 from a TRS-80 home automation product. We haven't changed our way of thinking about how to design for this environment in 30 years. And so the problem that I see is this. So when you have one device, you know, it has to be really, really generic. So this is, I call it generality of each device. It has to be really, really, it has to be really, really generic, and it's completely dependent on you to do everything, for you to make all the decisions for it. It has almost no autonomy. You know, when you have two devices, you can differentiate a little. You can do a little bit. So people are, this is basically where we are now in the world. We're still kind of like, people are still talking about the second screen experience in media. Ooh, two devices, right? You know, you can differentiate a little about what they do, and they can become a little bit more autonomous and a little bit more specific. You know, when you have three, you know, it's a little more in either in each case, or a little less general. When you go out, you know, and so on and so on. But the problem is, and you know, out here you get sensor networks, right? Out here, this is the sensor network universe. We have 1,000 devices. Each device necessarily has to work autonomously, and can be, and almost needs to be ultra specific. But to me, the interesting part, the interesting next challenge for us to think about and to work on is this space. How do you start designing for 5 devices, for 8 devices, for 10 devices, and have experiences that utilize all the capabilities to create a single experience using that number of devices? How do you manage a situation where those devices can talk to each other and can talk to other things? Right now, you know, it's going to be impossible for you to actually be able to control and think about all of these devices simultaneously. It's actually like your ability to think about this stuff kind of ends about here. But we have that many devices, and we're going to have more. And so we need to be able to think about that. We need to be able to think about it. And if we don't have good tools, either cognitive tools or literal tools, for designing this experience. And I think this is the biggest challenge. And so let me kind of, this is all the new stuff, so if I'm kind of stumbling a little bit, it's because I'm really kind of making this up as I'm going along. This to me is kind of our biggest challenge right now with the Internet of Things. It's not the hardware, it's not the services, it's not deploying new infrastructures, it's thinking about how to make a small but larger than 2 number of devices operate together to create a single experience. And we have some tools for this. Computer scientists, you know, on theoretical programming side, they have things like Markov chains and graph-based programming, you know, and things that model it. You know, just like the simplest Markov chain you can have. I guess the simplest one is actually a single, whatever. But if you ever try to wrap your head around this, it's really hard. You know, it's like this is a really, you know, Markov chains are a tough tool, right? You know, it's not a very good jumper. It's not Ruby on Rails, right? At least for me. And we're starting to get that. You know, we're starting. Some people are starting to work on the problem: how do you make a bunch of devices collectively behave in a desirable way, autonomously and collectively? You know, swarm robotics. You know, for those of you who are familiar with that, there's an entire genre of robotics now that's all about swarms of devices. So swarm robotics is actually pretty interesting, a reduction of the space that I just described. So instead of having a bunch of different devices having to figure out how to address a wide range of problems, you're actually having a bunch of identical devices addressing one problem. So this is like, but it's already moving in that direction. But it's like that's a reduction of the space. Swarm robotics is a totally new field. Like, it's barely there. Like, they don't have a lot of tools. But it's a start. And it's a start, eventually they will have tools for programming clusters of these devices that allow them to solve a general class of problems. You know, whether it's getting a soccer ball from one end of the room to the other, or maybe helping you watch Transformers on both your phone and your TV. Whatever. The interesting part for me, of course, as I keep reiterating, is that the hardware can all do this. There is no shortage of capability in our hardware today. The bottleneck is actually a lack of tools for compensating for the fact that our brains can't think in this way very well. And we have not yet leveled up in terms of our tools to think about how to do this. So what do these tools look like? And I don't have a great answer for you, but I'm going to give a guess and kind of end on this. It's more of a question than an answer. So I think the tools that we need are going to not work deterministically. They're going to work probabilistically. And rather than through hierarchies and through things that are predictable, the core idea behind the new set of tools is they're going to be distributed and they're going to be probabilistic. They're going to be things that tend in their collective towards a certain set of behaviors that we want. So, what models do we have for such tools? We don't have many, but I want to give you two. SimCity and Lemmings. You look at these as games, as old games. But really what they are is they're tools for helping people shape emergent behaviors and effects that trend towards a desirable conclusion, rather than making them, or even allowing them, to focus on specific rigid behaviors. So these are the kinds of models for tools that I believe are not going to only help us build the Internet of Things, which I think is not that exciting, but the Google of things, or the Facebook of things, or the Foursquare of things, the PayPal of things, or the Farmville of things. That is when I think things are really going to take off. Thank you.
Almost like a graduate course all by itself. I didn't know how you managed to squeeze in 15 minutes last time. This is amazing.
I talk 5 times as fast.
So I want to open the floor up for questions.
Thank you, that was fascinating. As you came to your final conclusion, you had me on the edge of my seat, and I was ready for you to go straight into nanotech or biotech, and some of these kinds of areas that are really coming to some of the same kinds of conclusions.
Dude, Lemmings isn't biotech to you? Sorry.
Like I said, I was on the edge of my seat before you got there, although I started this morning in SimCity, but that's a different discussion. In the sense of paying attention to the Sims, because it's about setting up the situation so the Sims do the work.
Right.
And that's the interesting part. The same thing about, looking at nano, looking at bio, looking at biological agents to be targeting, drugs or whatever else.
I mean, sorry. Did I interrupt you?
I'm just curious as to whether your teams in PARC has been exploring the bio or nanotech angles of the same idea.
Not from this perspective. I will tell you what so I think that the relationship is that this is a lot more like gardening than it is like an assembly line. And so that's the but I think it's all an analogy. I think that if you look at the way that from my perspective the biotech is actually going to be in a direction that's more like software and less like gardening. So if you look at synthetic biology is all about software. It's about essentially treating genes like software. And in that case, it's not using that aspect of it. And nanotech right now is still in the kind of let's make a tiny wheel spin space, which is awesome, but it's not really I don't think it's. I don't think that we're not quite in the let's make green goo instead of gray goo space.
I have no knowledge. But
So
from the distance, it looks as if it's following the same principles as you're describing from the perspective of super single purpose probabilistic gas battery.
Yeah, I think that where this is actually closer to a lot of the big data stuff, which is all about identifying emergent properties. It's all about identifying and controlling emergent properties in large systems, and that's I think where this is going. And we don't have really great tools for controlling the emergent properties of large systems, and in that sense, it's kind of the same problem.
A lot of what you spoke about was mostly focused on it seems consumer facing. What are your thoughts on things that aren't necessarily being driven by human interaction, but it's just pervasive and around us, and maybe it's more industrial in approach and that aspect of things?
That's the more infrastructural stuff that I talked about at the beginning. It's not. I think it's happening a lot, but it requires there are a couple of different ways. There's essentially bottom-up sensing and actuation, the Japanese dosimeter project that was done by Shigeru Kobayashi and Haiyan Yang after the nuclear accident, where they used patch bay and super cheap dosimeters to create maps of Japan that were at a much higher resolution and were updated much frequently than the official maps. And that was essentially done as a completely grassroots bottom-up level. I think that's a very rare case and more an exception than the rule, primarily because people don't give you access to a lot of their devices. And if you want access to the actual device's capabilities, you will have to own the device, and that requires a large infrastructural investment, which then puts you into the scope of building out large technological infrastructures and having the capital investment for that. So those inherently become projects that are that are done by large institutions, and thus have the goals of large institutions, and thus I think are not actually as sort of transformative or interesting because of that. Although, you know, some of the largest, most interesting kind of Internet of Things projects I know about are like done by the Navy.
Let's take two more questions.
Yeah, you mentioned at the beginning, you sort of gave a definition. It was really a list of technologies, and it's sort of like, you know,
cheap isn't a technology.
What's that?
Cheap isn't a technology.
Yeah.
Well,
it sort of is, right?
What's an emergent property of a whole bunch of other stuff?
Sure.
Yeah.
One of the things that I sort of perceive as a whole, as you get more devices, is battery. And I was wondering, like, do you think that that's going to be a limiting factor as you get more devices that they charge?
Yeah. Batteries are going to be both a challenge and a pain in the ass. So, so the thing about ubiquitous computing, as a guy I once knows, that ubiquitous computing is going to mean ubiquitous dead batteries. And at the same time, you know, we need that. You know, the value of a lot of those things is really high. Of the effects is very high, so we want that. So, and unfortunately, battery technology is, you know, if you look at, I once had a slide where I looked up kind of the kind of Moore's law curve and whatever the one for storage is and the one for memory is, the one for batteries is. The battery one, you know, it's like that plane that leads up to the Rockies. You know, it's flat, 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 while everything else is kind of shooting up into the sky. You know, batteries have increased in efficiency like an order of magnitude in 20 years, whereas everything else has increased 3 orders of magnitude. So yeah, to wrap up, I hope somebody comes up with an awesome, super cheap, super recyclable, high power battery solution.
The gentleman in blue, last question.
What about multiple users? So most of the systems you've talked about, you seem to imagine one user with many devices.
Yep.
Do you think of that as a separate problem or an easier problem, or how does that interface with the problem of many devices?
I think it's, to be honest, I've been really thinking about one user to many devices more than, like the many users to one device is typically the design of an environment rather than the design of a device. Like that happens when you're designing an environment much more than when you're designing a small device. And in that situation, I mean, I don't have a great answer. I think it's a thing that's going to happen, but in the same way that, like, you know, you don't pass your phone or your digital camera around very much. Most other devices going forward, or you know, your Fitbit, are not going to be shared that much. Whereas your TV is, but that's then a different user experience design challenge. That's a design challenge and essentially a situated device in an environment. So that's the best I can do. I don't have a good answer.
Thank you.